Hi, great students. Welcome to Lecture 6-5, Part 1. This begins under Roman numeral V, molecular geometry. Under A, properties depend on bonding as well as molecular geometry. Under B, polarity and geometry determines the molecular polarity, P-O-L-A-R-I-T-Y, the uneven distribution of molecular charge. This influences forces that act between molecules in liquids and solids. Under C, there are two theories. One accounts molecular bond energies, and the other describes orbitals that contain valence electrons of molecules' atoms. Under D, what is called the VESPR, VESEPR theory, Figure 6-20 and 621 on page 183 and 184. Number 1, molecules as hydrogen, H2, and HCl are made of two atoms and must be linear, LINEAR. Number 2, larger molecules are based on VESPR theory, which stands for valence shelled electron pair repulsion, states that repulsion between the sets of valence level electrons surrounding an atom causes these sets to be orientated as far apart as possible. Number 3, group 2. An example is BeF2. Be, beryllium, does not follow the octet rule. The two shared pairs that is shared with fluorine atoms will be orientated as far away from each other as possible. Figure 6-21a shows this molecule drawn. Bond angle is equal to 180 degrees and the linear, LINEAR, shape. AB2. Number 4, group 13, the example is BF3. Boron does not follow the octet rule. The three shared pairs that is shared with fluorine atoms will be orientated as far away from each other as possible. Figure 6-21b shows this molecule drawn. The bond angle is equal to 120 degrees and is what we call trigonal planar shape, TRIGONAL, and then the word planar, PLANAR, shaped, AB3. Number 5, group 14, the example is CH4. The four shared pairs that is shared with hydrogen atoms will be orientated as far away from each other as possible to maximize the distance. Figure 6-21c shows the drawing of this molecule. Bond angle is equal to 109.5 degrees and is called tetrahedron shaped. TETRAHEDRON shaped. A in AB4 follows the octet rule. Number 6, table 6-5, page 186. The boron can be a single type of atom, a group of identical atoms, or a group of different atoms. Shape will be based on forms in table, but different sizes of boron distorts the bond angles, making angles larger or smaller than the table angles. We will then go over some sample problems 6-5, which deal with the VESPR theory and unshared electrons, and then we will practice in class. And again, this concludes Lecture 6-5, Part 1. Thank you very much.